There we go. Okay, so today is Tuesday, and today we are going to review probability rules. So there's a little joke for everybody. All right, we have a sheet of probability rules. Well, I have to make sure that the video gets the joke too. All right, all your probability answers have to be between 0 and 1. For rule 3, that's basically the definition of how you find probability, your successes over your totals. The complements rule we'll use a little bit. We'll use it more tomorrow and in your multiple choice tonight. If two events are disjoint, then they have no outcomes in common, and they give you this rule for or. I would kind of like you to cross that out. We're only going to use the general addition rule. Or is equal to that U symbol. And if it's disjoint, it means the probability of A and B is 0. So this general rule still works, even for disjoint events. All right. Disjoint also means mutually exclusive. Those two words are the same. And then we have a few more things we're going to add below, so I'll give you a moment to catch up. And so far today, most people have said this is a good review day. Delaney and Marcus will probably be bored to tears because they did this less than 3 weeks ago, pretty much. Actually, they did it right before the winter break. I don't think anybody else in honor statistics last, like just you had Ms. Fogger? Okay. So today should be really easy for you, I'm hoping. All right. Okay. Put a warning sign beside that formula because you can only use that formula if you're told that you have independent events. And usually events aren't independent and usually events aren't disjoint. Occasionally we run into them. And then there's really only 2 independence rules because that second rule we've just repeated. And those are the rules we use for proof of independence. All right. The good thing for the 3 of you that have just done this is these first 2 worksheets you have not seen, and the homework tonight you have not seen. So it's not like you're redoing things you just did a few weeks ago. Okay, ready for example number 1. Example number 1 on page 2 of your probability packet. And isn't that the truth that the probability of someone watching you is proportional to the stupidity of your actions? Yep. At least it seems to be the case for me. All right. So this right here is a graph of kind of what this first packet is talking about, or this first problem on page 2. You can't see this too well, but the red stands for 2011, and the green is 2012, and the blue is 2013. And this is where people get their news. This says TV, this is online, this is newspapers, friends and family, radio, magazines, and this is social media. And my guess is if we put the year 2021 or 2020 in here, what would we get? I think the TV would be a lot lower and social media would grow. Although I have to say, I probably watched more news on TV in the year 2020 than I have in the couple years before that, just because of the pandemic. For a while, I was making sure I caught Governor DeWine's Thursday announcements, and then with all the election stuff, we were definitely watching the TV for that. I think, if I told you this before, tell me, one of the cutest little things, maybe the only cute thing to come out of the most recent election was little kids' opinion about what was going on the TV. Did I mention this already?
Yeah.
I did, I think, in your class. As parents were watching the election unfold night after night, which went on for over a week, right? Supposedly the kids were saying to them, "Oh, Mom, do we have to watch the math show again tonight?" They were tired of the math show. So that's what they, and I mean, that's pretty sophisticated smartboard stuff that guy was using all the time. He definitely liked playing with that. All right, so this is an actual, only 10 years old question from an actual AP test. And we will, the one thing I should say is make sure that you are not being tempted by your technology, i.e. your phone. So just like, if you're feeling like you're going to be playing with your phone, just hang it in your pouch and put it under your desk so your teacher doesn't get frustrated. Because this is kind of important review for you. All right? And Lily, you have been selected to read this first sentence, or it's actually 3 sentences, if you would.
For now?
Yep, go ahead.
Okay. The advertising agency in a large city is conducting a survey of adults to investigate whether there is an association between the highest level of educational achievement and primary source for news. The company takes a random sample of 2,500 students in the city. The results are shown in the table below.
All right, so I like the fact that they did a random sample. That's good. In case you don't remember, random samples help reduce bias by what Mrs. Bogger and I have said. It sprinkles the weirdness, which just means basically you're creating roughly equivalent treatment groups, or in this case, a rough picture of what the actual population is. The next thing I would like to do is put in some abbreviations so we don't have to write this all out. I'm going to call not high school graduation with a superscript C. That means high school graduation not. High school graduate but not college graduate, I would call that HG, and college graduate we'll call CG. And then we have newspapers, local TV, cable television, internet, and none. I would probably just use the word none. All right. So, Henry, you have actually been randomly selected. You can believe that or not, but it really was random. Could you read the sentence in part A for us?
If an adult is to be selected at random from this sample, what is the probability that the selected adult is a college graduate or obtains news primarily from the internet?
All right, this is an or. And if we go back to our formula sheet, our or is right here. It's called the general addition rule. And Henry, are you able to take the rule that's on that paper and change it into our abbreviations up here? The probability of what?
Wait, what? I can solve it if you want me to do that.
Well, I want you to put it into the new notation. So this notation says the probability of A or B. I want you to swap out the A and B for the new abbreviations.
All right. Probability of. Okay. you get the P and then the
Yep, parentheses.
right, college, so CG,
Yep.
and then a line.
And what's the symbol for
with
or?
the U.
Yep, the symbol for or is union,
And
or internet,
and I,
equals the probability of
CG,
college graduates
times the probability of
plus the probability of internet.
oh yeah, minus A and B.
Yep, minus the probability of CG and I.
Yeah.
So whenever I do these probability problems, here's a good way to imagine what's going on. Somebody went out and randomly gathered 2,500 adults and invited them to come to this big auditorium. So we have 2,500 adults in this auditorium. Somebody gets up to the speaker or to the microphone and says, hello, could you please stand up if you're a college graduate? Okay, thank you, sit down. Now, could you please stand up if you get your news on the internet? Somebody's counting them all up. Okay, thank you. Now stand up if you are a college graduate or you use the internet for your news. And so those people stand up if they're one or the other or both. So this is an inclusive or. It's kind of like when somebody asks you, would you like sugar or cream in your coffee? You can have both if you want. So that's why we need to subtract the overlap because that's been counted twice. All right. I don't care if you have that written out whenever you do this. To me, the second part after the equal sign is optional, but I do want you to write out the first part. So I do want you to answer this question, put the probability of college graduate or internet, and if you prefer to use the word or there, you can. Just make sure you know the symbol for or. And so now, Walker, what's the fraction for college graduate?
Would be 693 over 2,500.
Yep. As long as the word given is not in the prompt, the denominator is going to be your total. All right, Rania, how about how many people use the internet?
687.
Yep. Yep. Minus the people we've counted twice. Nick, Nelson?
245 over 200, over 2,500.
Yep. And now that equals something, and I'm going to find out what that equals by finding my numerator here. All right, I'm going to take 693 plus 687, take away my 245, and I get 1153. I'm sorry, it's 1135, isn't it? I just dyslexic myself. All right, dividing that by 2,500, I have picked somebody to answer that question. So if you're daring, there's a 1 out of 18 choice that you won't be selected. Well, that's not true. I already used up 5 of them. So you have a 1/13th probability of being selected. So I will wait momentarily in case you want to try to figure that out, in case it's you. And I think the person I selected has started to put this into their calculator, so I will give them a few more minutes. It's very good of me not to give away with pronouns. All right, Mr. Yost has been selected. Do you have that fract or that decimal?
Or,
This answer right here.
oh yeah,
Oh, he hadn't finished.
0.454.
Yep. Now nope, it doesn't say how many decimals to use. On the AP test, if there's only a few decimals, like 3, 4, or 5 decimals, especially when you're doing probability, just Give them all the decimals. All right? Now is the time for me to be completely open and honest with you. If this were the day of the AP test and you were doing this problem, the only information you would need to have down to get full credit for this question is right here. That's the only thing, that's the minimum you can have down. However, you're not in the AP general classroom, you're in Mrs. Garrett's classroom, and Mrs. Garrett requires notation and work. I actually don't care if you give me that. I would rather see all the other stuff. Why? Well, because I'm mean and nasty and I like to use up lead as much as possible. And because I want to make sure that you are understanding what's going on. And I think it will be helpful to you sometimes later on in the problem. So in Mrs. Garrett's class, that ending stuff is not good enough. You have to have the notation and you have to have the 3 fractions. Or you can do it a little bit a different way. So if you know how to do this a little bit differently, I don't think it's less fractions though. Like you could add the 188, 75, 147, 245, 38 plus 401 plus 41, but that's more fractions. That's more work for this one. So, all right. Any questions on the OR? The OR takes the most work. All right, Rachel, if you could read, Rachel Fender, if you could read B for us, please.
If an adult is to be selected at random from the sample, what is the probability that the selected adult is a college graduate and obtains news primarily from the internet?
Okay, there's the dreaded and. This is the warning. Has the word independent appeared on this paper yet? From the top stuff we've read already down to this part? No. So you can't be multiplying to get this answer. You have to get it a different way. All right? But Rachel, do you have an idea of the notation that I should put down?
Wouldn't it be CG and then the and symbol and then I?
Yep. And does anybody want to volunteer to tell me how to do this? Do you know how to do it? Okay.
So,
Go ahead, Rachel.
don't you just look at like you go to the college graduates and you find where they interlock with the internet?
Yep.
It's 245 over 2,500.
And what do you know? We've already kind of done that right there, up above. In fact, they should have asked this question first, but they didn't. That's okay. All right, what's the probability I'm going to pull Michael Yost out of here again? Let's see. Everybody's back in, so find out what 245 divided by 2,500 is. All right. The other thing I'm going to say is that so far we haven't had the word given or conditional probability. That's coming up in the next one. So if the word given or the statement, this is a conditional probability, has not been in the prompt, then the denominator is always going to be the total, and the numerator doesn't always necessarily come from a subtotal. It did for the first part, sort of. All right, so who, I won't even look, is it going to be? I have a 1 out of 18 chance of calling Michael again. It's Walker.
0.098.
0.098. All right, why do I always have a leading 0? Well, in publications you're supposed to. That's why all math books do, because you don't want people to think that that's just a little fleck on the page or something. Do I care if you have the leading 0 or not? No, just make sure that people can see your decimal point. All right, I'm the teacher, so I'm supposed to kind of have that. All right, conditional probability. Who have we not selected yet? Philip, could you read C for us?
What is the probability that a randomly selected adult obtains news from the internet, given that the adult is a college graduate?
All right, so in case you don't remember this, do you remember it, Philip? You want to try?
I do not remember it.
Okay, the probability that you are getting news from the internet, and the symbol given is a straight line down. Given college graduate. Now, this is one place that I think that formula on your purple paper, or whatever color it might be pink, I think that formula can hurt you here. So if you do this right now, the probability of I and college graduate divided by the probability of college graduate, I think that's going to hurt you, and I don't recommend that. What I recommend you doing is thinking of conditional probabilities like this. Conditional probability is under the condition that you are whatever they say, now answer the question. So you put a restriction on it. So this is basically saying, given that you're a college graduate, so Philip might have a magic foot, but I, maybe, have a magic pen. So given the condition you live in that column, come on. Oh, not very magic, is it? There we go. It was tired. So how many people live in that column? How many of the 2,500 people in the auditorium have been told, okay, go away, we don't need you, just stay if you're a college graduate? How many people are staying? 693 people. That means about 1,800 people just got up and left because they don't meet the condition of being a college graduate. So that's like, I actually in my mind picture a conditional probability. All right, some people just got up and left because I am not interested in their characteristics anymore. All right. There we go. So, for conditional probability then, Mr. Whitmore Rich, how many people have the condition of being a college graduate?
693.
Excellent. I was just checking to make sure you were paying attention. And of those 693, how many of them get their news from the internet?
245.
So do you see a theme here? This question is only interested in college graduates and people who get their news from the internet. Is that the way that it always works, Mrs. Garrett? No. But it is the way that this problem works because they're trying to get you to do something here in the very last step. All right, and if you put that into a fraction, you get a nice repeater going. And that repeater, Adam? Yep, 353535. All right. And now, what the elf on Rudolph wants to be. Hermie the elf wants to be a dentist because he wants to be independent. In case you've watched Rudolph recently. Rudolph, Unicorn Cornelius, and Hermie the elf want to be independent. I think they do a little song about it, actually. Yep. And they even go to the island of?
Misfit Toys.
But the Lion King there says, nope, can't be independent here because of some reason.
Yeah.
What's the reason? No, because this is just for toys, and they're not toys, I guess. They're like living human beings, I think. Even though the toys on the Misfit Island sing and dance and do everything else, and squirt jelly instead of water. And what does the dolly do?
Doesn't she cry?
Yeah, but why is that misfitish? I don't know. It's just done. I don't know. Okay. All right. So, how do we do independence? Well, you have two main ways, and they are listed right here. And I'm going to do both of them for the sake of you haven't done this for a while. And if you write kind of smallish, you'll be able to fit the both in down there. I'm going to do the way I don't like first, because I think the other way you can actually think about it and why it makes sense. So this is way number 1. Is the probability of college graduate and internet news person equal to the probability of college graduate times the probability of internet? I'm kind of like sitting here thinking, is this true? Well, I can look up above and see that this is equal to 0.098, and I want to know if it equals the other side. Well, I don't have any of those calculated out, and even if I did, you should use the original fraction. So I can use 693 over 2,500 times 687 over 2,500. The reason I say use the original fractions is because if you have rounded to get an answer before this point, then it's not going to work out like it should. So somebody multiply those together. Who is going to be selected? It's going to be Hannah. What do you get when you multiply that times that?
I got 0.076. We're going to
Is that good? Yeah. So are those equal? No. So don't leave them equal, because the AP people will be like, what? They should know that those two numbers aren't equal. So I'm going to go back up and put a not equal sign. And then I'm going to write a conclusion, but I'm going to say that conclusion here for a minute, because I'm going to do it the way I prefer to do it. This is way 2. And after I do it this way, I'll explain why I like this. Okay, so way 2, I look at the conditional statement that they had me do, which is internet given you're a college grad. Does that equal the probability, and is it the I or the CG that I need? Look at your formula sheet. It's the I. And I'll explain that in a minute, how you can remember that without having to look. Well, I already know that this is 0.3535. And the probability of I is that fraction over there, 687 divided by 2,500. And so I want to see if these are equal. All right, so what is 687 divided by 2,500? Mr. Nelson has been selected to give us that answer.
0.2748.
Are those equal? No. So here's what we write for our final conclusion. Well, it is exactly the same start. It doesn't matter which way you chose to do it. I think I'll put it in red. The event being a college graduate and the event getting news from the internet are not independent. Why? Well, because, and here's where you tick the way that you did, I'm going to tick the second way. The probability of internet knowing that you're a college graduate is different than the probability of somebody just getting their news from the internet. So, You should be able to explain what those two decimals mean. If all the 2,500 people are sitting there and you ask those to stand who get their news from the internet, there's a 27.4 or 27.5% chance that you're going to have somebody stand up. But if I say to you, hey, wait a minute, the person I picked is a college grad, do you change your mind about the probability of them getting their news from the internet? Yes, you do. That probability goes up about 8% to 35%. And doesn't it make sense that somebody who's been to college and graduated from college would be more likely than a general anybody to get their news from the internet? Because what do you do in college? For what? Research. So you learn how to trust what you find on the internet. You don't just look it up on Wikipedia. There's sites that you can go to. Is it really?
Yeah.
Okay. So it makes sense that if you graduated from college, you're more apt to own technology and you're more apt to be on the internet daily anyway, and it makes sense that you would get your news from the internet, right?
Right.
Okay. So, any questions on this? You don't have to do both ways when asked to find if things are independent. You just pick away. My preference is to pick something with a conditional because of what I'm about to explain here in just a moment, but Mr. Whitmore Rich has a question, sir.
So I was just, I was looking at like the doll from Rudolph the Red-Nosed Reindeer. So
Yeah, isn't her name Susie?
I don't know what the name was.
Okay.
But I guess there wasn't actually anything wrong with her like on the outside. The problem with her was that she had low self-esteem and she thought that no child could ever love her.
Oh. Well, we appreciate you using your cell phone to look that up for us.
Well, you were. No. He just pulled that up. It's great.
Yeah. Yes, Marcus.
Couldn't we also say that it's independent because the college graduate and I doesn't equal 0?
Because the what?
College graduate and I doesn't equal 0.
That means they're not disjoint.
Okay.
Yes, that's coming up shortly. Yep. But they are not independent because I've changed your mind by giving you a little piece of information, which is what we're going to put on page 3 before we take a break. So flip over to page 3, please. All right, page 3, that little symbol is at the bottom. And it actually tells you what question D was that year. I changed question D out because we're not able to answer the real question D yet, as what is the name of the statistical test that should be used and what are the degrees of freedom. Some of you might be able to answer this. Do you know what kind of test you use when you're faced with a table like this with two categorical variables? Chi-square. Yep, CHI square. If you've taken advanced bio, you have seen this before. Or AP bio. And last year, this was not actually part of the AP exam. This year it's supposed to be, and we will get to it before May 13th, I promise. All right, so let's think about independence. So please write this on your page 3. The first thing you have to do is know the probability of an event. Like the probability of X equals some number. And I will give you an example right here. The probability that you are a student taking AP Stats is 50 out of about, somebody said we had 800 here at Kenston. So if I know if that's right, how many students we have. All right, we'll use 900. The probability that you're taking AP Stats this year at Kenston High School is 50 out of 900, which is equal to 5 out of 90, which is point what? 0.04055555. Is that right? 0.05 repeating. Does anybody check it out? Okay. Because you guys know that anything above a 9 is the numerator repeating, right? On what I think? Let me test this out. Yeah, almost. Not really. I guess if it's 8. All right. Okay. So that's the first thing. You know probability. The second thing is this. Now you get a bit more information. All right? So now somebody tells you, okay, oh, by the way, Y is also in play too. If this new probability is equal to the same old answer from before, then you have independence. But if the probability of X given Y equals a new answer, then you are not independent. There is some relationship going on here. There is some kind of confounding variable in the background that you're not aware of. So I honestly kind of wish that on these formula sheets right here, and I'll go back to that other page, I almost kind of wish it was like, okay, what's the probability of A? Now, does it stay the same given a new piece of information? I almost wish it was this way, because I think this way makes sense. I know the probability. Okay, now you've told me this happens. Yeah, I'm not changing my mind. That's independence. So I really wish, and I told the other classes this, I really wish our, in 1776 that we would have had a different outcome. I petitioned my state senator to ask that the Declaration of Independence have a name change. I think it should be called the Declaration of Mutually Exclusiveness, or the Declaration of Disjointness from England. Because that's what we think of independence as. We think independence is disjoint, and not in statistics class it isn't. Independence does not mean you have nothing in common. All right. Now, let's do this example again. Let's suppose I tell you I have selected a freshman. What is the probability that they're taking AP Stats given that they're in 9th grade? Anybody? It's 0. I can't say sophomore because I do have 2 sophomores this year. I usually have like 5 or 6 sophomores that take AP Stat. And it's really nice for them because they get a really nice AP score as one of the first AP tests they ever take. Because I'm pretty confident that I've never had a sophomore take AP Stat and get less than a 4 on their AP exam. So it's, you guys should all be reaching for a 4 or a 5. If you really are paying attention and trying really hard, right between a 4 and a 5, a 4 and a 5 should not be a problem. The difference between 4 and 5 is usually only a few multiple choice questions, to be honest. So, everybody in here is capable of getting a 4 or 5. All right, I can say that now. Last year, I believed that until we went remote. And then a lot of people who should have gotten 4 or 5s got 3s because, well, they just kind of lost interest. Okay. This brings up a very other important point. 2 events can never be disjoint and independent. Because of this right here. There are no freshmen in AP Stat. So if I tell you I have a freshman, you know exactly what the probability is of them being in AP Stat. It's 0. Events that are separate can never be independent. It just can't happen. Disjoint, I can put into a Venn diagram. Independence, I can't. All I know for sure is if 2 events have a prayer of being independent, they must overlap. But then there has to be more to it, and you have to do the proof. So that's not good enough to be independent, but that at least is crossing the first hurdle. How do you picture independence? You do a stacked bar graph. And if those stacked bar graphs are broken up the same way, I should have put that higher. Let's see if I can move it higher. Oh, I can't. Okay. So let's do like low right there and put circles in here. Okay, that's 2 independent events because their segmented bar graphs are identical. There's no association, so they're independent. This is independent. All right. Any quick questions before we take a little break for a moment? All right, Lily, if you want to, you can go get a drink or something. Give yourself like 2 or 3 minutes, or you can do this brain break with us, whichever you want. All right. Okay, everybody up. Stand up. Put your hands out in front of your face. Take your right hand and put it on your left ear. And take your left hand that forms the letter L and put it on your forehead. Usually it's nose. You don't have to put the L on your forehead. You can just put your hand on your forehead. All right. Usually it's supposed to be on your nose, but it's COVID and we're not allowed to touch that. Okay. So I'm going to count to 3. I'm going to say 1, 2, 3, and then I'm going to say out switch. So you're going to go like this. 1, 2, 3, out switch. Now your right hand should be on your forehead and your left hand should be on your ear. All right, we're going to do it again. 1, 2, 3, out switch. 1, 2, 3, out switch. Does anybody know the easy way to do this and how I can do it without like getting all tangled up?
Just think about one thing.
I'm thinking about my right hand. I'm thinking right now, ear, ear, ear. 1, 2, 3, out, switch. And the other hand just goes where it's supposed to. At least it does for me. Okay, so start thinking of where you need to go. 1, 2, 3, out, switch. Did that make it easier? A little bit? Okay, let's wiggle the fingers. Put these 2 fingers up. And then we're going to go in and then over or out in, up, in, over, in, up, in, over, in, okay? Put one over and one up. Ready? In, switch. In, switch. In, switch. See if you can keep doing that kind of quick. All right, now let's get really tricky. Start one in and one up or out. And this you kind of have to think about a little bit. Ready? Switch, 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 switch. And I'm just good at that because I've been doing it a long time. Just like people who can spin their pencils on their hands, like I can't do that. I've tried, but I haven't practiced enough, and I don't care enough to practice. Yeah, this is hard. You're like this. Oh, wait. You just have to do it a while. I've been doing it for years, so. All right, any other questions, any concerns? Marcus is up, that's good, that's okay. He's had this like just a couple of days ago, so you gotta remember it. All right, now it's time for a Venn diagram, woohoo! And the reason it says think purple on top of that one page is because I usually try to put all the probability stuff on purple paper. I put all the descriptive statistics stuff on pink paper. I put the experimental design stuff on yellow paper. I put linear regression on green paper. And I put all the inference stuff on blue paper. So when you're taking the AP test, you can be like, oh, this is a blue problem. And then it helps connect all the little nerve wires up there in your brain a little better. That's why people who have synesthesia are so smart, because they see all the words in color, and that helps. Or that's one way you can have synesthesia. Some people, when they hear music, they smell different things. Like synesthesia is really unusual. It's when your senses react in ways that us normal people don't get them to react in. But we had a girl here not too long ago. I had actually, there were two girls here. I had one of them in class. She was the one that heard music and would smell different things. But then the other one had perfect pitch. I can never think of her name. I think it was Lindsay. Anyway, she would come over and we'd be like, oh, Lindsay, what does my name look like? And so Lindsay would look at the name and she would say, oh, well, it starts off green and fades into blue. And, oh, that's so cool because your CHE is sparkling. I'd be like, what? But it was kind of cool. So she is long gone, or we'd invite her over from calculus to do it. Oh, Cook was her last name. Lindsay Cook, I think. It at least began with an L. All right. Okay. Lily is back. And we are going to do, how can I have not erased this already? Like, what was I doing? All right, we're doing this page. Page 4, hot dogs and sparklers, woohoo! Now I will tell you that the one you have for homework is a little harder to start. So we'll probably do that and then we'll be done for the day because you guys are like half awake maybe. Not that I'm complaining. I mean, without Henry being up front, we don't have quite the chatter going on between Mr. Phillip and Mr. Henry. Exactly.
Is it that gentleman who was reading that?
Well, gentleman is kind of a, I don't know.
I'm walking out for that one. I'm gone.
Okay, bye.
I'm gone. Heck no, Mrs. Barrett.
Don't let the door hit you.
Today's episode of How Far Will Go Go.
Yes.
No.
What was speaking? You can't get back in because that's locked. All right. Okay. So, who knows the trick to starting off of a diagram?
Two circles.
Yep, you draw 2 circles, but where do you need to start? Where should you start? In the center. In the center. So we have our hot dog circle, and we have our sparkler circle, and that doesn't give me much room to write in the center. And so I will draw those again, giving myself, there you go. So we have hot dogs and sparklers, and we're going to pick somebody randomly, just in case Philip wants to come back in. We'll let him come back in. We're going to pick somebody randomly to read to us what's going on here. And that person is, we have not heard from Tyler. Tyler, why don't you read for us?
Survey of local villages revealed that 58% of all families still have them by 4th of July picnics. 23% celebrate sparklers and 7% people.
All right. So what number should I place into my Venn first? Oh, I picked Philip. Philip? All right, Mr. Nelson, what number should I place first?
58%.
Well, we always have to start, Philip, where do we always start a Venn diagram? You were selected, but you weren't here.
I wasn't here. Sorry.
Do you know where to start Venn diagrams?
Um.
Well, so you know this.
Well. Well, you need to draw the first circle.
Where should the first number go?
I don't know.
In the middle.
In the middle.
So Nick, what's the number for the middle?
7%.
Yes, I'm gonna put 0.07. If you don't like working with decimals, you can make that just a 7, but then you're making sure you change all your answers into decimals and stuff like that. All right. So now it says that 58% of the families serve hot dogs. That means the whole hot dog circle has to add up to 58%, but I already have 7% in there. So the hot dog crescent, as I call it, should be what? 0.51? Because now the 07, which looks like a 6, and that's bothering me, and that whole thing is bothering me, so we're just going to start all over again. There we go. 0.07 and 0.51 is here. And the whole sparkler circle of Delaney is supposed to add up to what?
0.16. Oh, the whole thing is
2, 3. So how'd you get the 0.16?
I subtracted 23% minus 7.
Yep. And now there's one step left, Mr. Whitmore Rich. Everything should add up to what?
1.
But let's see if it does. 51 plus 7 is 58. If I add on the 16, I get 74, which means how many families out there are not celebrating the 4th of July, or otherwise known as disjoint day, mutually exclusive day? 0.26. That's a percent of people that aren't celebrating at all, and I'm feeling like I didn't add things up right, but I think I did. I think it's okay. All right. Huh? Okay, thank you, Henry.
Yeah, no problem.
Yes, no problem in knocking down your shield. All right, Miss Peters. What is the probability that a randomly selected family served hot dogs at their 4th of July picnic? What do I do to show the probability of hot dogs? What do I have to do in that drawing? Don't forget, yep, there you go.
Shoot. You shade it.
Yep, but what part of it do I shade? All of it or just some of it?
Some of it.
Actually, I shade the whole circle.
Is it?
Yep, because that's the hot dog people. So make sure when you put the answer in here, you're putting the whole circle, not just a piece of the circle. And that would be 0.58 because that's what they told you in the prompt, 58%, right? All right, Rania, you're up next. What is the probability that a randomly selected family served hot dogs and celebrated with sparklers? What do I shade in this particular Venn diagram to show the hot dogs and sparklers? Yep, I shade the overlap ellipse, or whatever you want to call that shape. And the notation is hot dog and sparklers. And Rania, what is the probability there? Yep. 0.07. All right, this is a conditional because I see the word given. What is the probability that they served hot dogs given that they had sparklers ready to go for later on? Well, I don't have the rectangle anymore because all I'm interested in is the sparkler circle. So I am only interested in the following people. Maybe. There we go. I'm only interested in the people who are in the sparkler circle. How many people, what percent of families are in that sparkler circle? 23. And what piece of that circle are people who also are serving hot dogs? The 0.07. So, if you don't put that letter S in there and you happen to draw the circle this way, oh, it's thinking that I'm doing my magic ink still. Let me get rid of that. Okay. All right. If you draw it this way and you don't have any letters anywhere and you put that down as your answer right there, you are going to lose credit for the drawing part. Because I'm going to take it off of here and think you're talking about what's the probability that you have sparklers given that you ate hot dogs for your picnic. So make sure you're keeping things straight. And this is going to require a little bit of math because it's 0.07 divided by 0.23. And that is 0.3043. All right. Now to the question that Marcus was thinking about earlier. Are the events disjoint? Note to self, most events are not disjoint and most events are not independent. But every once in a while you do run into them. So let's see. What is the probability of hot dog and sparklers? 0.07. So the answer is no. They're not disjoint because the probability of hot dog and sparkler equal 0.07. If disjoint, the probability of hot dog and sparkler would equal 0. So this last piece is important because it tells the AP person grading your test that you understand what disjoint means. Do you have to have that? Here's the thing. You never know who is in charge of the problem on the test and what bee they have in their bonnet. And if they happen to have my students coming to my college never understand that disjoint means there's no intersection, then they're going to expect you to have that there. So I'm just going to ask you to put both of them or you get credit off. Because that way you'll be trained no matter what the expectations are. That's part of the hard part of scoring well for me on an AP question is I don't know if they're expecting all the pieces, parts, or not. Okay, are they independent? Well, let's take a look up here. We have something all set up, right? We have a conditional, and thankfully we have the beginning of that conditional. That's not always going to be so nice for us, but I'm going to do this. I'm going to ask myself, is that true? And I happen to have both those decimals all set up. Is 0.3043 equal to 0.58? And the answer would be nope. So the event serving hot dogs at your 4th of July picnic, which I'm not going to write down, and the event celebrating with sparklers are not independent because probability of hot dog given sparkler does not equal the probability of hot dog. And one last thing that I think I did not mention earlier, and you don't have to write this down, but I want to know, why is the following not acceptable? Why can't I say the events serving hot dogs and using sparklers are not independent? Why is that unacceptable? Even if you see it sometimes in an AP solution, it's really not acceptable. Because? That's okay.
Because they could confuse it for the actual and event.
Yeah, they're thinking you're talking about this. And that's like really one event. It's not two separate events. So this is not allowed. You have to write that word, the event, twice. Or I'll take off. Just because I'm trying to train you right. Okay. Please go to, that's what we just did. Please go to, this is what we just did. Please go to the top of page 5 and draw the Venn diagram for me real quick. This is your first problem for homework. As soon as we draw that Venn diagram, I'm done. And if Phil wants to leave again, he can. Since we were telling him to listen to show. That you were what? Oh, it is very nice. It is very, very nicely circular. There used to be a guy at the middle school who could draw almost a perfect circle every time he drew it on the board. He taught there for like a year or two, but I think that was way before you guys. This Venn is different than the one we just did because they don't give you the middle. So what, pray tell, are we going to do? Somehow I've lost the table. Huh. Oh, where did the table go? Well, what I want. Is it still precipitating outside? It's just looked ugly all day. Okay, we want that one. Oh no, don't do that to me. Okay, I think we're okay. And we want this one. Somehow I've lost this one. All right. Marcus and Walker and Delaney are not allowed to answer this question because they just did problems like this. This was like the dog and the cat problem. Remember having the dogs and cats, owning dogs and cats last semester? Like 3 weeks ago? 4 maybe? All right, who knows what to do? Michael?
I don't know exactly how you do it, but don't you like do the thing of like the C and the subscript? It's like not the probability of like not probably like the not of one and the not of the other equaling each other or something.
Yeah, but you can make it a lot easier than that. What's the first number I'm going to put in this Venn?
0.02
And where does it go?
outside everything.
Yep. 0.02. 2% of people don't leave any food for Santa or his reindeer. And if that's true, then what does my double overlapping circle have to all tally to? 0.98. This whole stuff right here has to be 0.98. But how much is it actually if you add up those separately? The Santa circle is 0.85, right? And the reindeer circle is 0.45. And if you add those together, you get what? 1.3. 0.85 and 0.45 is 1.3. But you can't have probability above 1. And in fact, we were just saying that those two are only supposed to add up to 98. So that means the overlap must be 32. This and that add up to 1.3, but it's only supposed to add up to 0.98. So the overlap must be 0.32. The other way to think of this is use that or. The probability of Santa or the reindeer is supposed to be the probability of Santa plus the probability of reindeer minus the probability of Santa and reindeer. We just figured out that this was 0.98. We figured out that Santa was 85 and reindeer were 45. So the minus has to be 0.32 because you can solve the equation. So if this is 0.32 now in the middle, how much is the Santa crescent? How much is the Santa crescent? How much is that dog? Yes.
0.53.
Thank you. And the Rudolph or the reindeer crescent is going to be 0.13, I believe. So are we okay with that or not? Like, I can't tell if we're like, just like, it's way past our nap time, Mrs. Garrett. We are like,
We're okay.
okay, that's good. Because I didn't get to that, showing the other classes that, so. Your homework is to finish this page, and to do page 6, and to do all the A's in the multiple choice packet, which should not take you too terribly long now that we've set up that Venn. So that's your homework. The ones that you should show work for in the multiple choice are circled. And I'm trying, there are different places you can go to find out what your homework is. One of them is on the video that I'm going to stop doing here shortly, and I'll come back to that page if you need me to. So where is, oh, did I thought, yep, I did.